So hi everyone, welcome back to another video on the channel. In this video, we are going to discuss another problem in our DSA series, that is conversion of decimal to octal number system. So this is going to be exactly same as the decimal to binary video. You can definitely watch that if you haven't already. So this is going to be exactly same. In that video, we were recursively dividing the number by 2. Why 2? Because we were converting the decimal number into base 2 number system, that is binary system. So we were recursively dividing the number by 2, extracting the remainder, appending the remainder at every stage to generate a string, and at last we were returning the reversed string that is used to be our binary equivalent of the given decimal number. So in this video, we are going to do exactly same but with octal number system. As you already know, octal number system is base 8 number system. So here instead of 2, we have to divide the number recursively by the number 8 and extract the remainder and then reverse the string of remainders to get the required octal equivalent of the given decimal number. So our approach is going to be exactly same. Divide the number by 8 and extract the remainder before that, then divide the number by 8, then append the remainder into a string, then at last return the reverse string. And until how many iteration the loop will continue? Until the n value does not become 0. So now let's move into the code editor and code out the problem. So I could not find any code coding platform which gives the problem decimal to octal conversion. So I just used ChatGPT and carved out a similar lead code style problem. So here it says that we have given a non-negative integer n, return its octal base 8 representation as a string. Why as a string? Because as you know, the input size is 10 to the power 9, which exceeds the integer limit. So we cannot return the value as the integer or long or in long format. So we need to return it as a string. And we cannot use any built-in methods like integer to octal string. So there are many built-in methods in Java, like to octal string, to binary string, in different wrapper classes like integer long, which converts the number system that is given into a required another number system. So let's code out the problem with our given approach. So we need a string builder object first of all because we need to append the string repeatedly. And as you know, string is immutable, so we cannot append any new character into a string after it is formed. So instead, we are going to use the string builder object, which can append the new character because string builder object is mutable. So while our number is not equal to 0, we are going to extract the remainder of the number when divided by 8, and then we are going to append the remainder with our string builder object. So after that, we are going to divide the number by 8 so that we get the reduced number in the next iteration. Then at last, we are going to return string builder object dot reverse. We have to reverse it first because we need the string to be in reverse order, which is our actual required number. And then we have to convert it into toString because the return type over here is string type, not string builder type. So we need to return to convert the string builder object into string. So that is our problem. But if I run that, a test case will fail. I will let you know which one. So this test case failed. So when the input is 0, our output is nothing because we are not entering inside the while loop. See over here. When we when the number is 0, the while loop does not run at all. But we have to adjust that or accommodate that test case that when the number is 0, we have to return something. And as you know, the octal equivalent of 0 is also 0. So that is an edge case for this problem. So if our number is equal to 0, we just have to return 0. So that is an edge case that we have to handle over here. So we have to return 0. Then we have to run it again. And as you can see, this time all the test cases have been passed and our problem is successfully done and dusted. So thank you for watching. That's it for this video. Keep learning.